Good day, everybody. How are you all doing? Today, we are going to talk about hypothesis test for proportions. So I'll share my screen with you. Why do we do hypothesis test for population proportion? This is because we do not know the actual value of the population proportion. An example of that is, suppose I want to find the population proportion, which is P, of students at a college who has laptop computers. I cannot reach out to all the students. So I select a random sample of 50 students, say. Suppose out of those 50 students, 35, which is X, the small number, 35 students own a laptop computer. Then the sample proportion, which is given by P with the thing at the top called P hat, which is sample proportion of students who own a laptop computer, is X over N, or 35 divided by 50 is 0.7. So I still do not know the population proportion. I have a single point estimate of the population proportion, which is the sample proportion of 0.7. Next, I hypothesize, make an educated guess of the population proportion of students who own a laptop computer as population proportion equal to 0.68. How far is the sample proportion, which we have determined to be 0.7, is located away from the hypothesized population proportion? It is 0.7 minus 0.68 equal to 0.02. So my null hypothesis is population proportion P is equal to 0.68, that's 80, and my alternate hypothesis P is greater than 0.68, which is my alternate H sub A. We have to standardize the difference of P hat from P, which is 0.02, by the standard deviation of the sampling distribution of P hat, or which is also called the standard error. We know standard error of the sampling distribution of P hat is given by the formula square root P population proportion times 1 minus P divided by N, everything inside the square root. So in my case, the standard error is square root of 0.68 times 1 minus 0.68 divided by 50, which I can do in one shot in using TI-84. So I press second button and then X square, get the square root. Inside the square root, I type 0.68, which is the population proportion, hypothesized population proportion, times 1 minus 0.68. And that is to be divided by 50, and then I hit the entire button. Every bit of the operation is inside the square root. And I get the standard error as 0.066. Thus, the standardized test statistic, which is a characteristic of the sample I have collected, is the difference of the sample proportion from the hypothesized population proportion divided by the standard error or the standard deviation of sampling distribution, which is the difference is 0.02 divided by the standard error, which is 0.066, which is 0.303. What does that mean? That means the sample proportion P hat is located 0.303 times the standard error above the hypothesized population proportion of 0.68. Now I show you a standard normal curve. The center of the curve is Z is equal to 0. It's a bell-shaped curve. And I have determined my test statistic as 0.303, which is on the right of the mean at the center. Z is equal to 0. It's on the right of the center. Z is equal to 0.303. Now I want to find out what is the area under the standard normal curve to the right of Z equal to 0.303. We can use TI-84. We press second and then verse and select number 2, which is normal CDF. My lower is 0.303 or zero point 0.3. As I'm starting from there, my upper is 1e99, that is 1 exponent 99, 1 followed by 99 zeros. So I first type in 1, then second button, then comma on top of 7, which gives me the letter small capital E, 99. I type in 99. Leave the mu as 0 and sigma as 1 because this is the standard normal curve. I bring the cursor on paste and hit enter and enter. Hence, I get the probability of z greater than 0.303 as 0.381. Probability of getting a test statistic as at least as extreme as 0.303 is 0.381, which is greater than 0.05. So this is a high probability, and this is definitely not happening just by chance. So we failed to reject the null hypothesis. Why? Because the probability to the right of z equal to 0.303 is 0.381, which is greater than 0.05. You ask what is 0.05? It is the level of significance. What is level of significance is 1 minus confidence level. It is the maximum probability of rejecting H0 when it is true. That is the maximum probability of making a wrong decision. So since the area to the right of the test statistic is greater than the level of significance, we reject the null. We fail to reject the null hypothesis. We do not reject. We fail to reject the null hypothesis because probability of getting a test statistic at least as extreme as 0.303 is 0.381, which is greater than level of significance. So since I failed to reject H0, my conclusion is at alpha equal to 0.05, there is not enough evidence to support the alternate hypothesis, which states that P is greater than 0.68. Okay, so I will stop here today. If you have any question, you can type in a comment. I will respond to you as soon as possible. And please subscribe to my channel, and thanks for watching. Take care. Have a nice day.